Thank you very much. Okay. Good morning, everyone. My name is Alberto Bertoco, and I represent CAE. CAE is the Italian leading company in environmental monitoring and early warning system. The company was founded in 1977, so it's almost 50 years that we are working in environmental monitoring. We started by applying electronic and telecommunication in what was the manual measurement at that time. During the year, we are implementing different kind of environmental risk. Thanks to the new technology, we've been able to implement different kind of application from different kind of risk. So nowadays, we are able to monitor different kind of risks like hydrology, floods, meteorology, glaciology, wildfires, landslide, levees offshore, monitoring, water quality monitoring, radioactivity, tunnels, flood tunnels, and monitoring by images. Monitoring by images is really requested in the last years by our clients because they are not only willing to measure what's going on, but they even want to see what's going on, especially during events or during flooding. And nowadays, with the video analytics, we are not only talking about taking some picture of what's going on, but even trying to some more information from the image that we are taking. So almost 50 years of experience in early warning system and monitoring gave us the possibility to develop some best practice. So the best methodologies for us that we have to implement when we have to install and maintain a proper environmental monitoring system. So first of all, network design. So it must be purpose-driven. So we have to be sure what we are going to monitor. We are monitoring the meteorology, we are monitoring some flooding, we are monitoring some water quality. So depending on what we are going to monitor, we have to be clear what the technology we have to implement. Representative sampling. So we have to find the right place and the right sensor to get the data that really the client need. Optimal site selection. Still, again, according to WMO directives and according to the availability of some site, we have to decide where to position the station in the proper way in order to get the reliable data and the data that we want. Integration of technology. Nowadays, because of the open standards, we are able to implement different kinds of technology in the same system. I mean, for example, our logger, because we are the manufacturer of some critical devices, such as data logger, is able to implement open standards. So apart from implementing our sensor, we can even purchase integrated sensor from third parties that implement open standard like Modbus, SDI 12, 420 milliamps. So different kind of technology in the same system. Then it's very important to select the appropriate sensor. So depending on what we have to monitor, we have to choose the right sensor in the right place. Regular calibration maintenance. This is very important. We always stress our clients about the importance of maintenance. It doesn't make sense for us, in our point of view, to make an investment of a big network if you are not able later on to provide the maintenance. In our the majority part or half of the part of our turnover comes from maintenance contracts. So on a regular basis, we go in field at least twice a year to check the status of the equipment and calibrate the sensor, because we need the sensor to be calibrated to get reliable data in real time. And of course, then in case of emergency maintenance, we have to go in field and change something got broken. Data transmission storage is important again, because local storage can be important in case we are not able to transmit data in real time. But first thing, when we try to project a monitoring system, an early warning system, we must be sure that we have at least one transmission means available. Better if we have two. In Italy, we work mainly with civil protection, so data must be delivered to our clients in real time, especially during extreme event conditions. That's why we rely a lot on UHF radio network or VHF, whatever it is, because it's a dedicated network. It's not affected during emergency, like can be a mobile. It doesn't have high latency like satellite. So we try to stress and to tell our clients to implement a radio network, a proprietary radio network. Data management, so we are talking about mainly the data center. So we supply the software for system management, data visualization, and alert dissemination. We even support our clients to define the proper hardware in order to avoid any problem at data center. For example, a backup on the server, a not standby backup for the server can be very important in case one server fell down during an emergency. We implement quality assurance mechanism, both at data logger and then in the data center too, according to WMO directives. We rely on metadata management, so not only storing the data related to the station, so the name of the station, coordinates, and this basic information, but every time we go in field to make some maintenance intervention, we have a software tool, so our technician has a tablet, then upload in the tablet all that they have done in that session. They have changed something, they have calibrated the rain gauge, they have find some problem. So we have an historic report of what's happening in every single station. In order to avoid to go in the same station several times for the same problem and to have the historical data of everything. Data sharing and dissemination is very important. We were saying before that the weather doesn't have boundaries or borders. So it's very important to share the information among different institutions. With our software, it's possible to interchange information in a standard format between different institutions. Training capacity building is at last is very important to train our clients about our technology in order to be independent in case we are not able to support them or they don't want to support to be supported. In some cases, especially abroad, we after the installation we provide the spare parts, but the client itself provide the maintenance over their own network. Okay. So all these practices, all these methodologies lead to to our idea of system architecture for an early warning system, monitoring an early warning system. So on the left, we are monitoring some kind of environmental risk from rain and temperature, landslide monitoring with a wireless mesh network, hydrological monitoring with wireless transmission to the data logger. The center, the brain of the monitoring system is the data logger, which collect all the data and in real time can transmit data to a data center with different kind of transmission means. Usually, it's better to have at least two transmission means, one as a primary and second one as a backup. Data center, the people in charge of the supervision receive data and can decide what to do with this data, can spread some alert to the population, for example, via voice calls, WhatsApp, SMS, whatever, or can alert local devices. At the same time, the data log, which is equipped with some intelligence, can, based on some threshold already uploaded in the data logger, can decide to activate local alerting devices. This is very important to reduce the reacting time between the event and when you have to alert or do something to save the population. So we are the manufacturer of what we consider the most critical components. We've been producing equipment since for more than 45 years. We are always trying to produce reliable devices. Why? Because it's our job, because they must work, especially during extreme conditions, and because we believe that we are not providing to our clients equipment. We have to provide data, reliable data in real time. That's why we need to have tough technology. We are implementing standard interfaces in order to integrate different kind of tech, not only ours, but even technology coming from third parties. We are implementing redundant elements in the sensor. For example, the tipping bucket rain gauge implements two reed magnetic reed. So in case one got broken, magnetic reed is the element that count the number of revolving of the tipping bucket. So in case one element got broken, we have a second one that can still working. Implement diagnostic sensor. So from remote, same for the rain gauge, there's an optic sensor. Then on a daily basis, check if the funnel is clogged, if there's some leaf or something inside. So there's this optic element that detects that it is clogged. So we have to go in field and clean the tipping bucket rain gauge. Another diagnostic sensor is to check if the electronic spirit level is horizontal or not. If the sensor for some reason is not horizontal anymore, we receive the alert in the data center and we can go in field and check what's going on. And nowadays, of course, we are trying to implement the new emerging trends and emerging technology in our network. So Internet of Things, we already implemented the MQTT and COP standards for Internet of Things sensor, which are cheaper compared to the standard sensor that we are using in our market and low power consumption. So it's becoming a very trending technology. We're trying to implement artificial intelligence, especially at software level, and remote sensing coming with a lot of data coming from, for example, satellites or radar. We are based in Italy. Our market is Italy, but we have implemented several projects abroad from Asia to Latin America. This is an example of Vietnam is our second market. This is an example of a big network implemented abroad for a total of 345 automatic weather stations, different kind of monitoring station from hydrological, meteorological, rain station. And the first project implemented in Vietnam, we implemented the UHF radio that helped a lot the client to receive data, especially during flooding. During flooding, the mobile coverage is weak, is congested, sometimes it doesn't work at all. But UHF, you can, first of all, install the radio repeater wherever you want. So on the top of a mountain, you will not be flooded. And you can receive, even if the internet connection is not working, you can receive data in real time because you have your UHF antenna receiver on the top of the building where the client is based. This is different example of, on a smaller scale, of an early warning system. This is Ecuador. We are talking about Luis Vargas Torres Island, which is located close to the sea. So when the river rise, the river level rise, and the sea cannot take the water coming from the river, there's some problem of flooding in the island. So we have installed some water level station and rain gauge on upstream, just to check if the water level is rising and if it's raining, because raining is the major factor of flooding. We have another water level just close to the sea we have installed, and then some sirens all along the island based on automatic threshold decided by the client, because we are able to install and make work all the devices, but the threshold are based on the client's experience about their problem. So based on one or more thresholds, so the combination of intense rainfall and the water which is rising, they can alert the population with some sirens. Okay, that was all. Thank you for all your attention. If you have any questions, otherwise I will wait for you at the booth, because I know we are very, very tight with time.